Hi, Professor. This is Nima Jafari, and this is a recording demo for my part two project um, of the basic calculator. So last time we had just the CLI, but this part we are supposed to start implementing the GUI. That kind of you want us to have this to match the Windows, not the GUI, but like the buttons that it has and like the features that it has. It should it should have the same functionality. Um, and we want a demo with the report file and also our code. So my code is kind of getting heavier, so I have it in my repository, same repository as the first one. Um, I actually have to change that because it's not a CLI calculator anymore. It's just a basic calculator uh, with double GUI. Yep. So it's a basic calculator with double GUI made for COM 585 class. So the first part I actually had was the just the CLI calculator that on this one I also added to GUI. So what I did is that I took the main like parts that actually do the calculations like binary operations, the cores, the calculator engines into a calculator.core folder. And next what I did is that I pushed the CLI only files like a UI and the input for the CLI to the CLI folder, and then I created a new folder for calculator.gui that uses this core. Um, and if I want to show you the UML design of this new file, it's in my report as well. You could see that this is our new UML design. So we have a calculator GUI that uses the calculator core functions, and we have a calculator CLI that again uses the calculator core. So this keeps our project file pretty clean. Now going to the folders, you're gonna see that the CLI is the same. So for I have a README file that explains all this how it works. So the calculator core, it's a pure calculator logic, operation state, percentage behavior history, memory code. And in calculator CLI, I have the console app, and in calculator GUI, I'm using the Avalonia desktop app to. So I used the Avalonia and .NET to build the GUI. The features, it has the same basic operations, advanced operations such as power of whatever you want, square root, reciprocals. I have standard calculator percentage behavior and optional memory mode in CLI. So for CLI, as I explained in the part one, you can have memory or no memory, but in standard mode for the GUI, you always have memory because it will show it to you. Um, we have a running history list. Which is new for GUI. It's new as first, including expression plus result entries, and this is how you can run it. But first, let me just explain some of the code. So this is just a solution that you have to run. So let's go to CLI first, right? So we have our input class, input helpers. We have our program, main loop for the CLI, and the UI. This is the first part one, so let's forget about the calculator CLI as part one. Now part two changes. I have the binary operations, which is the enum defining the supported binary operations. I have the enum representing the current calculator mode. I have the engine, the core engine responsible for tracking states, performing calculations, handling user inputs, memory history, and driving calculator logic. And for the calculator core, I have a custom exception type used throughout the calculator core in case the user makes a mistake, encountering invalid operations or error conditions. So this stays the same as since the mathematical functions are the equations are the same. I'm using the same as I did in the CLI as part one. So for example, if you divide something by 0 in the CLI, you would get an error. In the GUI, you will get the same error. So this is nothing new. This is just same math. The calculator formatter provides formatting helpers for calculator values like trimming unnecessary zeros, ensuring consistent invariant culture formatting. Math operations, same as the CLI version. So math operations don't change if you introduce a GUI. They stay the same. We have unary operations. which is enum for defining supported unary operations like square root and reciprocals. So these are just the two operations that I wanted to kind of like define separately. And then now let's forget the core calculator because that hasn't changed much either. The new thing is the calculator GUI. So I used Avalonia. So in the app.xml, this is the root application definition for Avalonia GUI. So this is where we kind of like pull the GitHub for Avalonia UI, repository, and we use it. We define our global styles and theme settings used throughout the app, like the fonts and properties like backgrounds. App.axaml.cs is the application's subclass that initializes Avalonia and configures the main window when the framework is ready. So this is pretty simpler. It just all it does is that it configures and initializes and loads the Avalonia. Calculate Avalonia space project. This is just the definition for the project and what it is using, like what themes and what version. So it's just the packages. Main window is the layout and style definitions for the calculator UI, including buttons, display, history panels, and theme settings, resource brushes. So in this one, we take of course, the repository Avalonia, but then I'm explaining and defining my own width of the window, height of the window, like what is the minimum width user can like collapse or resize the window to, what is the minimum height. Obviously I didn't put a max because you can make the app full screen. We have the backgrounds, we have the button accents for when you hover over the button. So these are the things that I added to make it look beautiful. We like what happens when you press the button, what happens to the background or foreground. So these are for the different buttons, and that's the whole point of this code. So the main window, XML.cs, is the code behind that main window. So it's the code behind the main calculator window. Handles user instructions, keyboard inputs, theme, history, toggles, and drives the calculator engine. And so for example, we have like icons here that's going to show. We have the button names here. Program.cs is the entry point for the Avalonia GUI application, sets up the app builder and starts the desktop lifetime. So this is all of this does is that starts the program for us. So basically that's all the code. It's in 3 different file folders, and I showed you the XML the UML diagram. So the only thing left is to actually run this, and I have included all the necessary steps. So you do a .NET build, but I've already built it, so it's gonna just build the Avalonia. I guess it did something, and then you can run the CLI, which is the part 1. So the part 1 of the project that I completed a couple weeks ago, you can run it here. You see, you can work with it in the CLI in the terminal, right? But the GUI, if you want to run the GUI, you run the calculator Avalonia, and ta-da! This is our default sizes, which matches and looks good on the screen. Kind of matches the Windows ones. This is my starts with a dark mode. We have a show history. If you see, I added this animation to make it look beautiful. And then you can resize it, you can make it big, but then there's a limit to how small you can make it because we don't want to ruin the user experience. Additionally, let me show you something. For example, if I can just work with my keyboard, I can input the numbers, I can put the multiplications, I can put the equals, I can press enter to calculate it. Obviously, alphabets don't work because only numbers work. Anything in the numpad, or if you want to like do a square root, there's all the, in my report I also included all the buttons and all the keyboard inputs that are the shortcuts you can use if you don't want to like click on the screen. For example, you see, you can also click on the screen and do all the math, but if you don't want to click on the screen and do the math, you want to just use a keyboard, you can do that. Just have to, for example, like just use your keyboard inputs that are pretty it uses the same exact keyboard inputs as the Windows standard calculator, Although I also added some more shortcuts for the keyboard that I thought they were helpful. For example, if you want the power, in Windows actually they only have power of 2, like square, but I actually thought it would be better if you have an advanced version of power, so you don't only want the power of 2, you can also find power of anything. So it can be like 8, and then to the power of whatever you want, 9, and I can also do the same thing and with my keyboard without even touching this, right? C is clear. So I can do 8 with my keyboard, pressing to the power of 9, pressing return, it does the calculation. Now let's look at, obviously this button works too, that one works too, and now let's look at the history. So we have a history here. When you click it, it opens it, it shows 7 history entries, newest is first, so this is exactly what I started doing. And then when you clear this one, it doesn't clear the history because we don't want to lose the history. Or even when you do clear, it doesn't remove the history. If you want to remove the history, you have to, and everything is being added and appended at the end of the history. If you want to remove the history, you have to come here and press clear, and then it removes it, right? So, and then that's pretty much all we have. All the functions are operational. You can do 9, square root is 3 is added there. I want to do multiplication by 3. Uh, I want to multiply that by like 7. It's being added there. I realize I want to find the percentage, so I can be like 63 plus 10%, which is 6.3, and then you add it, and then you have 70. So everything is being added here. If we want to change the, now this is one thing that I added that none of the calculators have, because I love front end, so I added this was actually super hard because a lot of things that worked in the dark mode or in the normal mode didn't work in the light mode, and I had to, especially on the colors and the hovering on the keys when the colors change when you hover on them. That's the most complicated thing I actually did, and it took hours for me. So when you switch to light mode, it becomes really bright. Everything, the hovering works the same. It's the same exact thing. Um, so you have clear. The only difference is the color. So you can do it. You can, same with also in with the history open, you can resize the whole window. Let's hide this history. Make these the normal thing, and that's it. You can just play with it, multiply them, clear it, and then you can see 1 divided by 0 doesn't work because like it shouldn't. And yeah, it's pretty much the same as this Windows calculator. You can also use anything from your keyboard with the shortcuts, and that's pretty much it.